In this lesson, we're going to continue our work with quadrilaterals. We're going to talk about trapezoids and kites. The first thing I want to do is make sure that we understand what trapezoids and kites are. Okay, they're both of them are quadrilaterals. Okay, but they have special properties. A trapezoid is a quadrilateral that has only one pair of parallel sides. Okay, so it has, rather than having two pairs of parallel sides, it's only got the one pair of parallel sides. The parallel sides, the two sides that are parallel, are called the bases, and the non-parallel sides are called the legs. Because of that, the base angles that are formed by base angles are formed by the base and one of the legs. And as you already know, the sum of all the interior angles of a quadrilateral is equal to 360 degrees. That's something that I just wanted to remind you guys of, because that's something that we will need to use to um, to solve some of our problems. Okay. Now, if the legs of a trapezoid are congruent, if the two legs are the same length, then it's what we call an isosceles trapezoid. All right. A kite, on the other hand, is also a quadrilateral, but it has exactly two pairs of consecutive congruent sides. All right. So the congruent sides are consecutive. All right. So just a real rough diagram. A trapezoid has parallel sides. Okay. All right. Like that. And a kite looks like that. Okay. So that's what we mean. That's what we're talking about in this lesson. Right. So the first um, couple theorems that we're talking about are talking about isosceles trapezoids. Make sure that you're going to copy these into your notes. Okay, so first first one says if a trapezoid is isosceles, then each pair of base angles is congruent. Remember, the base angles are the angles that are formed by the bases, each of the bases, and the side. So what it means is that what this is saying is that each pair of base angles is congruent. So the base angles that are formed by GH are congruent. Okay, so it doesn't matter, because if it's an isosceles trapezoid. Okay, so G this one and H this one are going to be congruent, and then the base angles that are formed by the base FJ, those two are congruent with each other, but not with GH. Okay. If a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid. So that's just basically more or less just saying the converse of that. It says that if you know that one set of base angles are going to be congruent, then because of that, we know that the other set is going to be as well, and we know that the two sides are going to be the same length. Right? And a trapezoid is isosceles if and only if its diagonals are congruent. So if you have the diagonals, that's the easiest way probably to figure out if if it's an isosceles trapezoid, is to find the try find the diagonals, and if the diagonals are congruent, then it's an isosceles trapezoid. So pause the video and copy these three theorems into your notes. All right, so the mid segment of a trapezoid is a segment that connects the midpoints of the legs of the trapezoid. So remember, the midpoint is the point where is right in the middle of the length, and both sides of the midpoint are congruent to each other. This midpoint is also, the mid segment is also sometimes called the median of a trapezoid. Okay, the theorem that we're talking, the trapezoid midsegment theorem, says that the midsegment of a trapezoid is parallel to each base, and its measure is half of the sums of the length of the bases. So, in other words, you're going to say AF plus CD divided by 2. Okay, so that's what they have here. I would have said AF plus CD divided by 2. Okay, so we're going to do several problems figuring out what the mid-segment is, or using the mid-segment to figure out what the length of a base is. So pause the video and copy these this stuff into your notes as well. All right, one last set of notes that you need to copy down before we start on the examples is two terms about kites. If a quadrilateral is a kite, then its diagonals are perpendicular. Remember that the last lesson we talked about rhombi, and we said rhombi were perpendicular. Well, this is the same thing, and there again, this looks very much like a rhombus, except for two of the sides are longer. Okay, and remember, a rhombus has all the same sides. Okay, so this says that its diagonals are perpendicular. It means that they cross at 90 degrees, right here in the middle. And if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Only one pair, exactly one pair. Okay, so in other words, J and L in this case are the congruent ones. K and M are not going to be congruent because of the length of, because the sides are different lengths. Okay, so in this, the top one, B and D would be the congruent ones. All right, pause the video and copy these two theorems into your notes. All right, here it says find the measure of angle S. Well, angle S is right here. Okay, so we know that this is 63. This is because the two legs here are the two parallel sides. The two legs are 14, so this is an isosceles trapezoid. Okay, an isosceles trapezoid, and so we know, and it's a quadrilateral, so it is going to add up to 360 degrees. Okay, so we know that this is 63. Okay, because of that, we know that this over here is also 63. All right, so we know that 63 plus 63 plus 2 times x, because these are congruent to each other. Okay, these are congruent to each other, is equal to 360. All right. All right. So we have 63 and 63 is 126 plus 2x is equal to 360 minus 126 on both sides. We're left with 2 times x is equal to 360 minus 126. So that is 234 divided by 2. X is equal to, and I'm going to use a calculator here, 234 divided by 2 is 117. And if we look here, we can see that these two angles are indeed obtuse angles. Okay, so 117 would make sense. All right, and if we just wanted to double check, we could say 117 plus 117 plus 63 plus 63 is equal to, indeed, 360 degrees. Okay? All right, next example says that, okay, let me close that out. Okay, next example says find the measure of angle M. Okay, so M is right down here. We're going to use the same thing. Okay, we see that 21 and 21, so this is an isosceles trapezoid. This is the angle we're given is 142. Okay, 142. So we can say 142 plus 142 plus 2x is equal to 360. All right. So 142 plus 142 is 284 plus 2x equals 360. Subtract 284. All right. 360 minus 284 is 76. So 2x is equal to 76 divided by 2. Okay. X is equal to 38, I believe. 76 divided by 2 is indeed 38. Okay. So the measure of each of these angles here are 38. Okay. So angle M is 38. Find the measure of angle D. All right. Now we know this is a kite. Okay. So we know that B and D are going to be congruent. All right. So we're given the other two measures. So we can just say, once again, 36 plus 70 plus our two congruent ones, 2x is equal to 360. 36 and 70 is 106 plus 2x is equal to 360. Solve. Minus 106 minus 106. 2x is equal to 360 minus 106 is equal to 254. Okay, divide everything by 2. Okay, x is equal to, divided by 2, 127 degrees. Okay, so x is equal to 127 degrees. Right, so angle D, and you can see that's obviously an obtuse angle. Okay, find the length of side RH. Okay, so one of the things that we need to remember also is the Pythagorean theorem. Okay, the Pythagorean theorem, it says that a squared plus b squared is equal to c squared if we're talking about a right triangle. Okay, right triangle. Okay, it says that a squared plus b squared equals c squared, where c is our hypotenuse. Okay, so here we're looking for RH or HR. Well, we know that this right here is a right angle. So what we have here is this right here is a right triangle with a side length 12 and another side length 20. So we can say 12 squared plus 20 squared is equal to c squared. Okay, so that's 144 plus 400 is equal to c squared. So that is 544 is equal to c squared. We're going to take the square root of both of them. This cancels with this. Square root of 544 is equal to c. And if I say 544 and take the square root of it, so that would be 23.32 is equal to c if I round it off to 2 decimal places. Okay? So a little bit over 23 units. All right? All right, for trapezoid HJKL, T and S are midpoints of the legs. Okay? If HJ is 14, so this up here is 14, and LK is 42, K, this is K down here. Okay? So basically, it says find the length of TS. And remember, according to that theorem you wrote down, to find this mid-segment, the length of the mid-segment here, you just take half of the sum of the two of the two bases. Okay, so we got 14 plus 42 divided by 2, which is equal to 56 divided by 2, and half of 56 is 28. Okay, so that's the length of TS. All right. Now suppose on this last one that we're doing, suppose that we're given the mid segment, length of the mid segment. TS is 10. So this is 10, and HJ is 7. Okay, so we're going to say 7 plus X divided by 2 is equal to 10. Okay, so in other words, we're going to say this is going to be X. This is our unknown value down here. Okay, so the two bases, 7 plus the unknown divided by 2 is equal to the length of the midsegment. Okay, so then all we do is just solve for X. So we're going to multiply by 2, multiply by 2. 2's cancel out. We have 7 plus X is equal to 20. Subtract 7 from both sides. X is equal to 13. All right, so the length of this is 13. And 7 plus 13 is 20. Divided by 2 is 10. So that indeed checks out. Okay, I should write that down, I guess. 7 plus 13 divided by 2 is 20 divided by 2 is 10, and so that checks. Okay, so make sure that you have all the notes copied down, and make sure that you ask me any questions if you don't understand something. We'll talk to y'all later on.